Hello, here I have my simple 12 volt to 5 volt Buck switch mode power supply with my custom feedback control circuit. I have a 5 volts output going for a potential divider, creating my feedback voltage of 2.5 volts. This goes into a window comparator measured against a high and low reference created by two Zeners. The output of the window comparator goes into an SR latch, and I've also got control signal from the two outputs of the window comparator into a NOR gate, which enables and disables a multiplexer. So the output of the SR latch, the Q signal, can be deselected if the voltage reference sits in between the window, so it doesn't hunt high and low continuously. So the output of the SR latch goes through the mux into a integrator, which that in turn modulates a 555 timer PWM control. I have a little Pro microcontroller. All this is doing is generating a 20 kHz clock for the 555 timer. The PWM output goes up through a couple NPN transistors to switch the MOSFET, which then in turn charge pumps the switch mode, the inductor, which is then regulated by 200 mic low ASR capacitors, and the feedback returns and gets modulated. Here is the scope image of my switch mode power supply. Yellow trace is the gate signal for the MOSFET control, and the green trace is the top of the Schottky diode. So I've got MOSFET, Schottky diode, inductor and regulating capacitors. Here I have a load box, so I've got selectable 250 milliamps. So this is 250 milliamps, 500 milliamps, 750 milliamps, and 1 amp. So here I have the timing on the oscilloscope for the gate signal and the switch mode power supply Schottky diode. And if I load up the power supply, you can see the PWM modulating the power supply. So that's at 250 milliamps. That's at 500 milliamps. That's at 750 milliamps. And that's at 1 amp. not too bad. $750, 500 milliamp, 250 milliamp, and no load. So this is my 12 volt to 5 volt Buck switch mode power supply with my custom feedback control. Anyway, that's it for now. Goodbye.